I've a job for you tonight, George, and I warn you now, it sounds like the easiest thing in the world. Take a proton, any old proton, one of the countless ones sitting in the water in this glass. Reach inside it, take hold of one of those little quarks we said were rattling around in there, and pull it out. Just the one. I only want to hold it up to the light and have a proper look at it. That's the entire request.
You can't. And I want to be careful about why, because the honest answer is far stranger than any excuse I could offer. It isn't that your fingers are too clumsy or the thing too small to grip. It's that the job is impossible in the deepest sense there is. Pull on that quark, and the force holding it only fights you harder. Pull harder still, and you don't come away with a quark. You come away with more particles, and not one of them is alone.
Hold on, wait. Pulling one out makes more of them.
More. Every single time. This is the one force in all of nature that grows stronger the harder you pull against it. Not weaker, stronger, without any limit I can offer you. So you heave on your lone quark, and all that effort, all that energy you're pouring into the attempt, it doesn't buy the quark its freedom. It congeals. It turns into brand new quarks, out of nothing but the strain of your pulling. You set out to end up with one, and you end up with several, and every last one of them is still shackled to a partner.
No, that breaks something in my head. Everything I've ever known pulls apart if you tug on it hard enough. Bend a paperclip back and forth, snap. Stretch a rope past its patience, it parts. And you're sitting there telling me this thing gets angrier the more you ask of it.
Angrier, and cleverer than merely angry. Here's the picture I'd have you hold. Take a bar magnet, a north end, a south end. You'd like a north pole all on its own, so you snap the bar clean in half. And what do you get? Not a lonely north. You get two whole magnets, each with its own fresh south, its own fresh north. Snap those two again, two more, and again each with both of its ends. You cannot by any snapping, however clever, ever arrive at a single naked pole.
Because the halves just grow the missing end back the instant you make the cut.
They grow it back, without fail, faster than the cut itself. And a quark is exactly like that pole. There is no snapping the bar so cunningly that one comes away by itself. The very moment you'd have your lone quark in hand, nature has already grown it a partner to face. You cannot make a stick, if you'll let me put it that way, with only one end to it.
A stick with only one end. I'm going to be up half the night on that phrase alone, you realise. All right, so this is the thing you've been circling for weeks now, isn't it? The reason nobody has ever, not once, in the whole history of looking, laid eyes on a single quark all by itself.
Nobody ever has. Not in the finest machine we've ever built, nor the finest we ever will. You can rattle them, you can watch what they do, you can be certain past all doubt that quarks are in there. But drag one out into the daylight on its own to hold up and admire. It has never once happened, and by the end of tonight you'll see it isn't shyness on their part, and it isn't a limit of our tools. It's law.
Law. Not a shortcoming of the equipment, not a thing we'll finally crack next century with a bigger machine. A law, flat out.
A law, flat out, and one we understand well enough now to say to your face, without flinching. It isn't that some lone quark is out there somewhere, tantalizing, hovering just past the reach of our fingers. It's that a lone quark is very nearly a contradiction in its own terms. Like asking to be handed the north of a magnet with no south attached to it. The words sit together neatly enough in a sentence. The thing they name simply cannot be built.
And I'd wager the whole strangeness of it sits on that one word you keep not quite saying. The force, the strong one.
The strong force. The one that does all of this. Last week we did its gentler cousin, the way two charges shove each other about across a distance. And I left you, if you remember, with a promise and a small threat attached. I said the next force along plays by a set of rules that would look, frankly, insane if I'd LED with them. Well, here we are, and I've gone an LED with the single most insane one on purpose, just to watch your face.
You have, and I felt every inch of it land. So don't go soothing me back down yet. Give me the shape of the night instead. What must I hold on to make a force that fights harder the more you flee it feel like anything other than a cruel little trick nature's playing?
3 things, and they lock together like the parts of a good joke. There's a messenger that carries this force, and that part will feel like a homecoming after last week, so we'll start there and let you breathe. There's the peculiar thing the force acts upon, which carries, I am sorry to tell you in advance, the worst name in all of physics. And there's a single difference between this messenger and last week's. One difference, tiny to say out loud, that tips the whole force over into the madness you just met. Get those 3, and the trap makes sense.
The worst name in all of physics. You've been quietly smug about that for a fortnight, and you still won't tell me what it is.
Not yet. If I say it cold, you'll picture the wrong thing on the instant, and then I'll spend the better part of an hour prizing the picture back out of your head. Let me earn it instead. Let me start you somewhere safe and familiar, and we'll walk toward the strangeness by broad daylight, one honest step at a time, so that when it arrives, you'll have built the floor under your own feet.
Somewhere safe. After you've calmly told me I can pour effort into a thing and be repaid in spare particles for my trouble. All right, George, I'll take safe. Lead on, where's safe?
Safe is last week. Safe is a messenger. Because for all its wildness, the strong force begins its life doing precisely what electromagnetism did. The ordinary, respectable, well-mannered thing, the thing you already understand down in your bones without my help.
Trading something back and forth, that was the whole heart of last week. 2 charges don't reach out and touch, they toss a little messenger between them. And the tossing is the push. The tossing is the pull. The force was never a hand. It was a game of catch.
That's it, carried straight over without a scratch on it. 2 charges, a messenger flung between them, and the flinging itself is the force. Not a hand reaching across a gap, a thing thrown across it. And what was the messenger last week? Name the courier for me.
Light, the photon. 2 charges throw photons at each other, back and forth, and that endless game of catch is the push and the pull. That was the lovely shock of last week. The messenger of electricity turned out to be the very same stuff as sunlight, running errands between charges.
The very same stuff, yes. Now hold that shape steady in your mind, and let me hand the strong force its own courier. And it has a name that sounds like a joke and is deadly serious. The messenger of the strong force is the gluon. Say it as it looks, gluon. And it does for quarks precisely what the photon does for charges. It flies between them and carries the force across the gap. Where 2 charges trade photons, 2 quarks trade gluons.
So every quark in that glass of water is, this very moment, quietly playing catch with its neighbours. Gluons flying back and forth by the countless million. And it's that endless game of catch that holds the proton together at all.
That endless catch, exactly, is the whole of what held together even means down at this depth. There's no rope, no hook, no little clutching hand anywhere. There is only the throwing and the catching, so fast and so ceaseless that from the outside it looks like one solid, settled, sitting thing. The proton is a game of catch that never once, in all the age of the world, drops the ball.
Gluon. Glue. All right, I forgive that one. It's at least honest about itself. Somebody looked at the thing that holds the little bits of matter together and reached, without shame, for the word glue. So far then, this is just last week wearing a slightly different hat. Charges and photons. Quarks and gluons. The same game of catch.
The same game, exactly. And I want you to feel how very much of it is the same, because it makes the coming difference land all the harder when it comes. A quark throws a gluon, another quark catches it, and that exchange binds the two of them. Quarks sitting close together trade gluons back and forth, tirelessly, and the trading holds them fast, the way the photon tossing held two charges in each other's grip last week. Nothing new so far, nothing strange. Yet.
I hear that yet. It's carrying an awful lot of weight for 3 little letters.
It's carrying the whole of the night, that yet. Because now I have to answer the one question I keep dodging. What does a gluon actually get thrown between? Photons get thrown between electric charges, and only those. A thing must have electric charge for the photon to care about it, to pull on it, to bind it in. A neutral thing, the photon sails straight past, utterly blind to it. So, what is the strong force's version of charge? What is the thing a quark carries that makes a gluon sit up and answer to it?
And this, I take it, is the badly named thing at last.
This is the badly named thing at last. Steel yourself.
I've been braced for a solid 20 minutes now. Out with it.
The strong force acts on a kind of charge, a genuinely new kind, nothing whatever to do with electric charge, a fresh property of the world that only the strong force can even feel. It comes in more than one variety, and the name that got hung round its neck, the name we are all of us stuck with forever now, world without end, is colour.
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 Colour. As in, the colour of this glass? The colour of your curtains there? As in red and blue and the…
No. And that no is the single most important thing I will say to you the whole night through. So let me say it slowly, and then let me go on and say it again. It has nothing to do with the colours your eyes see. There is no red quark, there is no blue one. There's no paint on them, no light coming off them, no faint little glow you'd catch sight of if only the thing were big enough to squint at. Not one scrap of actual colour lives anywhere in this whole story.
Then, George, I'm going to ask you the obvious thing, and I want you to sit right there in your shame while you answer it. If it's not red, it's not paint, it's not light, then why on earth, in the name of all that's sensible, would anyone ever call the thing colour?
Because physicists, and I say this with real love for my own kind, should not be allowed to name things. That is the true answer, and I'll stand by it. The polite answer is that there was a resemblance. One single, suggestive resemblance, and somebody reached for the nearest handy word to hand, and it stuck like tar and never came off. Let me show you the resemblance itself, and you'll see at once both why it was so tempting and why it was such a quiet catastrophe.
Oh, I would dearly love to hear the excuse. Go on then, make the case for the defence.
Here it is then. This new charge, this so-called colour, comes in 3 kinds. Not 2, mind, the way electric charge has its plus and its minus. 3 distinct varieties a quark is able to carry. And here's the tempting part, the part that did all the damage. Bring one of each of the 3 together in the same place, and they cancel each other out clean. They add up to a thing carrying no strong charge at all, a thing we call, and again, it is only ever a word, neutral.
3 kinds that cancel to nothing when you gather them up. And somewhere in there is your white, isn't it? I can feel it coming down the track.
You can feel it coming because you've a fine nose for a bad idea. Yes, 3 kinds of light make white. Picture 3 lamps up on a stage, a red one, a green one, a blue one, the sort you'd shine down on a singer. Each one alone throws its own colour on the wall behind. But switch all 3 of them on together, aimed at the very same patch of wall, and that patch goes white. The 3 of them add up to no colour whatever. That, only that, is the resemblance nobody could bring themselves to resist. A charge that comes in three kinds together making nothing, making neutral, the way three coloured lights add up to plain white.
So they went and nicknamed the three kinds of charge after the three-stage lights.
They nicknamed the three kinds of charge after the three stage lights, and in doing so, they doomed 100 years of students to picturing a little rainbow trapped inside a proton. Please don't be one of them. I'm begging you now on behalf of the whole battered field. The three kinds are simply three kinds. Three settings on a dial. Three flavours of one strong force charge. We could as easily have named them 1, 2 and 3, or hearts, bells and acorns off a pack of cards. There is no red anywhere in there. A quark is no more red than the number 7 is red.
The number 7 is not red, noted and filed, though I'll tell you privately, and just between us, 7's always felt a touch green to me, ever since I was small.
Then you are exactly the sort of soul who should never be let anywhere near the naming of a charge. So welcome, warmly, to the very club that named this one. But you've put your finger right on it, even joking, and I want it dead serious for just a moment, because the whole night hangs on it. The word is a label. The colour is not a colour. What is real, and all that is real, is this. There's a strong force charge. It comes in three kinds. Quarks carry it. Gluons answer to it. Every true thing about tonight lives inside that one plain sentence, and not a single word of it needs a rainbow to be understood.
So if I could somehow shrink myself right down and swim in among them, torch in one hand, I'd see nothing coloured at all. No red one, no green one, not the faintest glow off any of them.
You'd see nothing coloured at all, because there is nothing whatever in there to be coloured. Your torch would be shining light, actual light, the eye kind, onto a charge that has not the faintest thing to do with light in the first place. It'd be like shining a lamp on the number 7 to find out its true colour. The question doesn't even fit the thing it's asking about. The colour is a charge, and a charge has no look to it at all.
All right, I've let go of the paint, I promise you. Give me the proton then, spoken in this new language. You keep telling me week after week that a proton is 3 quarks.
3 quarks. That's where we stood weeks back, the 3 of them sitting inside. Now dress those 3 in the new idea. A proton holds 3 quarks, and here is the tidy, satisfying part. One of them carries each of the 3 kinds of colour charge. One of the first kind, one of the second, one of the third. And so, added all together, they come to neutral. They come to white. The proton, seen from the outside, carries no colour charge at all. Balanced, settled, quiet. Its books closed and squared.
Because it's got one of each, and one of each cancels the others down to nothing. It's the same trick as an atom being electrically neutral, then, as many minuses as pluses inside, so that from across the room the whole thing looks like it's carrying nothing at all.
A close cousin of that, yes, and a perfectly fair way to hold it in your head. The atom balances its electric charge down to 0 and sits there calm as milk. The proton balances its colour charge down to white and sits there just as calm. From arm's length, both of them look for all the world as though they carry nothing whatever. The difference, and it's the difference that's about to devour the rest of our night, is what happens when you try to look closer. Or worse, far worse, when you try to take one of the pieces out.
And that's the very bit I keep circling back around to. From the outside, calm, neutral, books closed and quiet. Reach a hand inside and it's the most violent thing you've described to me all night.
Calm on the outside, ferocious the instant you interfere. And those two aren't a pair of separate facts about the proton mind. They're one single fact wearing 2 coats. It reads as neutral precisely because the 3 colours are locked together in there so fiercely that nothing short of the tricks we're about to run can ever prize them apart. The calm is the ferocity, only seen from a safe distance.
Which is where we came in, right at the top. The pulling, the making more.
Which is exactly where we came in. But I don't want to spend that difference yet. I want to earn it honestly, coin by coin, because it turns on one single fact. And if I merely assert the fact at you, you'll nod along politely and not feel a thing. So let me first say one brief, kind word about the man who first saw the pattern, and then I'll show you the one thing that makes a gluon unlike any messenger you have ever met in your life.
A name. You've been so sparing with names all series long that I sit bolt upright whenever one finally wanders in.
A light touch only, for he had certainly earned it. It was Gell-Mann who first drew the threefold pattern up out of the mess, who noticed that the particles fell into neat, orderly families as though some hidden threeness in the world were quietly doing the organizing behind the curtain. The color idea grew up out of that soil, and that's as much of him as we need tonight. The pattern is the monument, not the man. And the pattern, you'll notice, is the three.
The three. Three kinds of charge, one of each making white, a proton carrying all three at once, and so, in the end, carrying none. I've got the whole cast assembled now, so you've been dangling this one difference in front of me like a watch on a chain for half the night. The thing that makes the gluon, not the photon. I want it now. Hand it over.
And you're truly ready for it now. You've every piece you need to feel the blow the moment it lands. So let me set the two messengers down side by side, the photon and the gluon, and ask one plain little question of each of them in turn. Ready? The question is this, and it's the whole hinge. Does the messenger itself carry the charge that it answers to?
The charge it answers to. So, for the photon, the question comes out as, does the photon itself carry any electric charge of its own?
Does the photon itself carry electric charge? And the answer, the very thing that makes light so beautifully, boringly well behaved, is no. Flatly, plainly, no. The photon carries the electric force between charges all day long, but it hasn't a scrap of electric charge of its own. It's neutral. It's a courier with entirely empty pockets. It delivers the parcel faithfully, and it never once owns a parcel itself.
And because it's carrying no charge of its own,
one photon takes not the slightest bit of notice of another. Cross two beams of light in a dark room, and they pass clean through each other. No shove, no swerve, no flicker. Each one utterly blind to the other's existence. The couriers ignore one another completely. They carry the force. They never, ever feel it themselves. That's the whole reason light is so calm, so orderly, so obligingly easy to add up. Photons simply do not touch photons.
right, calm, blind couriers with empty pockets, sailing straight past each other in the dark. Now do the gluon for me. The very same question. Does the gluon carry colour?
Yes. And that single small yes is the hinge the whole force swings upon. The gluon carries the strong force between quarks, and it carries colour charge itself into the bargain. Its pockets are full. It is not a neutral courier at all. It's charged up with the very thing it's out delivering. Which means, say it along with me, feel exactly where it's about to go. The gluons answer to each other.
Oh, that's... The messengers pull on the messengers.
The messengers pull on the messengers. The couriers are also, every one of them, customers. A gluon flying between two quarks is itself carrying colour, and any other gluon that happens to drift near it feels that colour and grabs. Where the photons streamed past one another like polite strangers passing in the street, the gluons reach out and seize hold of each other in mid-flight. The force reaches right into its own messengers and knots them together as they fly.
So the field between two quarks isn't a calm, spread-out haze, the way the field around a charge is. It's a thing that grabs at its own self, gathers itself, hauls itself in tight.
It hauls itself in. That's the very heart of it. That's the whole engine of the night. The electric field around a charge relaxes and spreads and fills the room because its messengers pay no mind to one another. This field simply cannot relax. Every part of it is grabbing at every other part, dragging the whole of it inward, tighter and tighter and tighter. And a field that pulls hard on its own self behaves like nothing you have ever once watched in your life.
And that's honestly it? That's the whole grand difference between them. One's got empty pockets and the other's got full ones.
That's the whole grand difference, and I promise you on everything that it is enough. Enough to build every single strange thing we meet tonight. The trap, the making more, the backwards twist at the end, all of it, out of that one small lopsidedness. It sounds like a footnote you'd skip. It is in fact the foundation the whole building stands on. Let me show you the first thing it wrecks, and it just so happens to be the big one.
Then wreck it. I'm braced again.
Think for a moment about how a force fades with distance. Last week's force, electromagnetism, step further away from a charge and the pull drops off, weakens, thins to nothing, because the photons spray outward in every direction and spread themselves ever thinner the further out they travel. Gravity does the very same. Back away from anything at all, and its grip on you loosens. Every force you have met in the whole of your life gets weaker with distance. It is very nearly the definition of the word.
Right. Near is strong, far is weak. That's simply how the world has always felt to a hand reaching out.
That's how every world you've ever laid a hand on feels. Now watch, closely, what these self-grabbing gluons go and do to that comfortable rule. 2 quarks, and the gluons flying to and fro between them, carrying the force across. But those gluons also grab hold of one another as they go. So instead of spraying outward and thinning to nothing, they haul themselves inward, together, into a single tight thread, running dead straight from the one quark to the other. The force doesn't fan out and fill the room. It ropes itself down into a line.
A thread. As though the field itself has been braided into a single taut cord, strung between the two of them.
Braided is just exactly right. And here I have to raise a small flag of warning, because I'm about to hand you a picture, and I don't want you mistaking the picture for the thing itself. What I'm about to describe to you as a tube, or a band, or a string, that is a homely little image for a subtle piece of physics, a way to see it in the mind's eye, and not a literal rope you could ever cut and coil round your wrist. Hold it loosely, but held loosely, and knowing what it is, it's the truest small picture we've got of a very deep business.
Understood. A sketch then, and not a photograph. But give me the sketch. I want something to hold.
The sketch is this. Between the 2 quarks, the self-gripping gluons pull the whole force down into a narrow tube. So think of a taut elastic band strung tight from the one quark to the other. And now here's the thing that has no cousin anywhere in your whole experience. As you draw the 2 quarks apart, that band does not slacken. Pull 2 magnets apart and their pull fades away between your hands. Pull these 2 apart and the band merely stretches, at the very same fierce tension it had before, refusing the entire way to loosen its grip by so much as a hair.
That's the part I simply cannot make ordinary. Everything I've ever stretched gets easier as it lengthens, or else at some point it gives up and breaks. And this one just stays exactly as tight the longer it's drawn.
Exactly as tight. Because it isn't spraying itself thinner as it goes. The gluons flatly won't allow it. So every single inch you drag that quark away from its partner, you are not loosening a thing. You are stretching a band that pulls back precisely as hard as it ever did, and you are pouring your effort straight down into it. And where does effort, poured into a band like that, actually go? It doesn't vanish into the air. It's stored. It piles up inside the tube as energy, more and more and more of it, the further out you pull.
So the band is a kind of savings account then, and I'm the fool paying into it. Every heave I make is another coin dropped in the slot, and not one penny of it ever comes back to me as a freed quark.
Not one penny of it comes back the way you were hoping. It all goes into the account, and the account only ever grows. There's no ceiling on it, no point where the band sighs and gives it up as a lost cause the way an honest rope would. It just keeps on taking your money, gladly. And an account with that much stored up inside it is sooner or later going to spend it. That's the very next thing to watch for.
Energy stored up in the stretch. All right, so now I'm standing here holding a loaded band. It's fairly screaming at me with all the energy I've been feeding into it. What is it that finally breaks the stalemate?
Here is where it all turns beautiful, and where a very old friend of ours walks quietly back into the room. Cast your mind right back to what we said weeks and weeks ago about energy and matter, that they are at bottom two faces of one single coin, that energy, gathered up thickly enough in one small place, can turn itself into matter, into brand new particles made out of nothing at all but the energy paid in. You remember the rule.
Energy becoming stuff. Mass conjured up out of pure energy. Yes, that was the deep one, the one that felt like a proper magic trick that just happened to be completely true.
That's the very one, and it is about to do something quietly wonderful for us. You keep pulling, the band keeps loading. The energy stored up in that stretched tube climbs and climbs and climbs, until at some point it crosses a line. There is now so much energy sitting inside the band that it becomes cheaper, easier, more natural for all that energy to stop being stored up tension and start instead being matter. And what matter does it choose to make? Why, the only kind that fits the bill. It makes a fresh quark and its partner an anti-quark, a whole new pair conjured straight out of the stored strain of your own pulling.
Out of the band itself. The band spends its own stored energy on building brand new quarks.
The band spends itself right down. And here is the truly exquisite part. Where precisely does the new pair appear? Right in the middle of it, at the very breaking point. So the instant the band snaps in two, the two fresh ends aren't left raw and gaping open. Each one of them has a new quark already sitting on it, neatly capping it off. You pulled and pulled to open up a gap, and nature filled that gap with new particles before the gap could ever quite come into being.
So I pull one quark away, meaning to isolate it at last. And by the time it's finally parted from its old partner,
it already has itself a brand new partner, grown right there on the spot, out of the energy of your own pulling. That's the magnet again. Do you see it now, dressed at last in its proper working clothes? You snapped the bar to get yourself a lone north pole, and the break grew two new poles to face one another across the cut. You pulled the quark to have it alone at last, and the break grew it a new mate before you could blink. You never, at any single instant, held a solitary quark in your hand. The universe simply will not permit the gap to stand there empty.
So I put in all the labor meaning to free it, and the labor itself is the very thing that builds its jailer.
The labor itself builds the jailer. Say that one back to yourself, quietly, the next time you can't sleep. And now you can see straight through to the answer to the very first thing I told you tonight, the thing that broke something inside your head. Pull and get more particles. Well, of course you do. The pulling makes the energy, and the energy makes the quarks. The harder you pull, the more energy you pour in, the more new pairs come snapping into being to spite you. You cannot win it. Your own effort is the enemy the whole way down.
And weeks ago, right back at the very start of all of this, in the first days, you made me a flat promise. You said plainly, you will never see a lone quark, never a single one out on its own. And you wouldn't tell me why, not then. This is the why, isn't it? This is what you were sitting on.
This is the why, and I'm glad, truly, that you carried it all this way to spend it here. That promise was a loose thread left hanging for weeks, and this is precisely where it ties itself off. A quark is never seen alone, not because they are rare or hidden or hard to catch in a net, but because the very act of separating one manufactures on the spot the company that keeps it from ever being alone. Aloneness for a quark is a state of affairs the universe edits out in the very instant it would otherwise occur. There is no procedure, none, not one anywhere, that ends with a single quark by itself.
A stick with only one end. You may saw the stick clean through wherever you please.
And every cut you make simply hands you two sticks, each with its own two ends. Saw those again, and now you've four ends. You will die of old age at the workbench before you ever once produce an end with no stick behind it. The quark is the end that cannot exist without its stick, and that whole trap, the entire business of it, has a single name we can finally afford to speak aloud. Confinement. The quarks are confined, bound in, walled up, and never ever to be met with out in the open air.
Confinement. So when your great machine's set to work, when you smash things together at some tremendous speed, hoping against hope to finally knock a quark clean loose, what is it that actually comes out the far side? Because plainly, from everything you've said, it is not a neat little quark laid out on a slide for you.
Never a quark on a slide. Picture the machine only in the very roughest way, a vast ring, miles and miles around, that whips protons up to a truly ferocious speed and then slams two of them head-on into each other. In that crash, a quark can be struck so hard that it goes hurtling clean out of its proton. The very escape you'd swear must finally, surely work. And for the briefest flicker of an instant, it is racing away, free. And then the band behind it loads and snaps and loads again and snaps again, over and over and over, all the way down its wake.
One snap after another, and each single one of them making a fresh pair.
Each one making a fresh pair, and each fresh quark grabbing greedily at others, all of them dressing themselves up in company far faster than you could ever hope to catch a single one of them bare. So the thing that truly comes flying out and reaches your instruments is not a quark at all. It's a spray. A tight, narrow jet of ordinary, bound-up particles, all of them pointing the way the quark was headed, like one bright spark that shatters into a whole shower of sparks in the air before it can ever land. We even name them for just that, sprays. Sprays of particles, standing in the exact place where one free quark once tried to be.
So the quark's own signature, in the end, isn't the quark at all. It's the crowd it cannot ever help but gather round itself.
The crowd is the signature. You never once see the runner himself. You see only the dust he kicks up as he goes, and from that dust you read off precisely which way he ran and how hard. That is how we know quarks are real. Know it now beyond the smallest doubt, having watched 1,000 of these sprays bloom. We have simply never, not once in all that watching, seen the runner cross the finish line alone. Because the line is a thing a quark is forbidden, always and everywhere, to cross.
I do rather love that your grandest, most ruinously expensive machines exist, in a sense, in order to fail. To go and try the one single thing that cannot be done, and then carefully photograph the wreckage of the attempt.
To fail, and to fail gorgeously, and to read the whole truth straight out of the manner of the failing. Every last spray is one more small proof of confinement, written out plain in the debris. A quark that reached for its freedom and dressed itself in company instead. We have never once freed a single one of them, and every fresh failure only leaves us the more certain of exactly why the thing can't be done at all.
All right, I've made my peace with the trap now, I think. Far apart, the band is merciless. It fights, it breeds fresh quarks, it never once lets go. So let me try to guess the rest, because I think at last I see the whole shape of this bully. Up close. Right up close, the two quarks nearly touching noses. It must be the very worst of all, the tightest, cruelest grip of the lot.
That's the natural guess. It's the guess very nearly everyone makes, and I love it dearly, because it is exactly wrong. Wrong in the single most wonderful direction there is to be wrong. It's the reverse. Right up close, the two quarks barely feel one another at all.
No, that can't. You've just spent a solid 20 minutes on a force that never, ever slackens for anyone. And now you're calmly telling me it slackens when they come close.
I'm telling you, the closer the two quarks draw to one another, the weaker the strong force between them grows. Squeeze them right up hard against each other, and the band goes soft, the grip loosens, the fierce tension drains clean away out of it, and they sit there almost exactly as though the strong force had gone and forgotten all about them. Nearly free. Rattling about, side by side, without a single care between the two of them.
So it's at its gentlest, exactly where I'd have sworn on my life it was cruelest.
At its gentlest, exactly there. And I want you to feel just how upside down that runs against the whole of the rest of nature. Every other force there is tightens as things draw near. Bring two magnets close and the pull between them swells. Close in on a charge and the shove swells. Fall in toward a great mass and gravity swells and swells. Near means strong, everywhere else in the whole of creation. But here, near means loose. Near means very nearly free.
And far means chained.
Far means chained. Close means free. The flat opposite, corner to corner, of the world you've lived in all your life. So picture the inside of a proton now, properly, for the first time. Those three quarks, jammed in tight and close together. Precisely because they are so close, the force between them is feeble and slack, and so they drift and jostle about in there, almost like three free particles, rattling round their own little room, hardly minding one another at all.
Hang on, wait, I love this. They're on holiday, in there, the whole time. Feet up, barely bound, not a care between the three of them.
On holiday is exactly the phrase, and I'm keeping it for good. Feet up, sun hats on, no chains they can feel anywhere on them. As long as they stay close together, it is the easiest, idlest life in all of physics. Nearly free, nearly ignored altogether by the very force that's supposed to be ruling them with an iron fist. The catch, the whole entire catch, the one line in the small print, is the door.
The door. They may lounge about all they like.
But let just one of them try to leave the room. Let one drift a touch too far toward the exit, and the holiday is over in a single heartbeat. The further out it strays, the harder the band hauls it back. And if it should make a real, genuine run for the door, the force rises and rises and rises until it's the merciless thing we met at the very top of the night. Until it would sooner breed a whole new quark out of thin air than ever let the runner slip out. They may do anything at all they please in there. Anything except leave.
So the quarks inside a proton are the most spoiled prisoners in the whole of the universe. The full run of the cell, comfortable as anything you like, right up until the very instant they reach out and touch the bars.
Bars they never once feel, never even know are there, until the moment they reach for them. And there it is. That's the pair of facts locked together at last, the two of them. Loose when they're close, ferocious when they're far. And the two are not at war with one another, mind. They're one and the same single law, only seen from its two opposite ends. Freedom when they're near, an unbreakable prison the instant they pull away. One force doing both of those things at once, out of the very same handful of gluons.
The same force doing both. I keep wanting to be properly cross with it, you know, and I keep ending up amazed instead, every time. Give me the honest name for the close-up half then. The trap has its name, confinement. What do we call the freedom?
We call it, when the quarks are close and nearly loose, asymptotic freedom. A real mouthful, I grant you, but all it truly means is the freedom they draw ever nearer and nearer to as they come closer and closer together. Freedom in the small, imprisonment in the large. Close up, they're all but at liberty. Drawn apart, they're in chains. The same two quarks, the very same force between them, and everything, all of it, hangs entirely on the distance you leave between them.
The same force doing both, from its two ends. Sit me in the wonder of it a moment, would you, before you send me off home to bed? What is this thing, really, when you stand right the way back from it and just look?
Stand right back then, and look at what the two of us have built here tonight. The strong force is a prison, but it is the very strangest prison there has ever been in all the world. Its walls aren't there at all while you're inside it. You can wander the whole length and breadth of the cell and never once so much as brush against them. The walls appear only when you try to leave. Reach a hand for the door, and the door builds itself up out of nothing, right there in front of your hand, out of the very effort you were spending to try and open it.
A prison whose walls only appear when you try to leave. That's, honestly, George, you could carve that one on a gravestone, and it would do.
And the mason who raises up those walls, in the exact instant you most need them not to be there, is the messenger. The gluon, all along. Because the couriers grip one another, the force ropes itself down into a band that never fades. Because the band never fades, pulling on it only loads it heavier. Because loading it makes new quarks, the runner is always, always caught in the act. Every strange thing we've met the whole night through came pouring straight out of that one small yes. The gluon carries the charge it delivers. Pull on that single thread, and the whole enormous trap unravels itself right back down to it.
The messengers feel their own message, one line, one, and out of it comes, no lone quark, ever, anywhere, no matter what on earth you try to do. All right, I feel as though we've genuinely crossed something real tonight, you and I. So where does all this leave us? In the big count, the forces. Lay them out for me.
Let's take the count. It's more than earned by now. 4 forces run the whole of the wide world. That was our map, drawn out weeks ago. And just look now at how many of them are already in our 2 hands. Gravity, still standing off apart from the rest, the holdout, the one that flatly refuses to sit down at the table with the others. We've set it aside for now, and it's still out there in the dark, waiting on us. Electromagnetism, done and dusted, last week, 2 charges trading photons across the gap. And now the strong force, quarks trading gluons, colour trapped fast inside, the whole prison sprung and understood. That makes 3.
3 of the 4. Gravity off sulking in the corner, refusing to mingle with anyone. And these 2 here we've now properly met, at last, face to face across the table.
3 of the 4, and only the one of them still left. And I'll tell you now, plainly, that this last one is the odd one out, in a way the other 3 simply aren't. Gravity, electromagnetism, the strong force, for all their quarrels and their differences, each of them does a job you'd recognize. They push, they pull, they bind. They hold things fast together, or they drive them hard apart. That, you'd think, is what a force is for. But this last force doesn't do that. Not really, not as its main line of work.
A force that doesn't push and doesn't pull, then what in the world is the thing actually for?
Its trade is stranger by far than any pushing or pulling. Its job, its real, actual, honest job, is to change what a thing is. To take a particle of one kind and turn it clean into a particle of another kind altogether. It doesn't shove things around the room, it transforms them where they stand. It reaches right into a quark and makes it a different quark than it was. It's less a force at all, in the old plain sense of the word, than an alchemist.
An alchemist. And there you go doing the very thing again, dropping a word like that on the table and strolling off toward the door.
I am, because it belongs to next week, and I have finally, at long last, learned my lesson about spending the surprise too early. But let me give you just enough of it to keep you up tonight, since that's become the tradition between us. The last force is the weak force, and it is the one that changes identities. It can take one kind of quark and turn it, outright, into another kind entirely. It can swap the very thing a particle is for something else and walk away whistling.
Turn one kind of matter into another kind. That's the old dream, isn't it? The one they used to burn people for so much as chasing after once upon a time.
The very old dream, and nature does it quietly, all the time, without a furnace and without the smallest fuss. And it matters more than any mere curiosity ever could. It is the reason the sun ever caught light in the first place. The first spark of every star that ever shone leans its whole weight on this one force, turning one particle into another. Without the alchemist, the entire sky stays dark and cold. It's also, as it happens, exactly why certain restless atoms quietly fall to pieces, all on their own, when no one's even looking.
So it lights up the stars and it breaks the atoms. The gentlest sounding one of the four goes off and quietly does the two biggest things on the whole list.
The gentlest name of them all, and the deepest reach of them all. And there is one more thing yet, waiting right at the far end of it, and it is the genuine shock of the whole course. I'll let you see only the very edge of it tonight. This force, alone among all four of them, can tell left from right.
Tell left from? A force with a handedness to it? What is that even supposed to mean, George?
It means this. Take a weak event, some small transformation, one thing quietly turning into another, and hold the whole of it up to a mirror. Everything else in all of physics looks perfectly at home in a mirror. The reflection is a thing that could happen, that does happen all day and every day. But the mirror image of a weak event is a thing nature simply never ever does. The reflection is forbidden. The world, right down at its deepest root, knows its own left hand from its own right, and only this one strange force ever lets the secret slip out.
That's not physics, George. That's a ghost story you're telling me. The universe has a favourite hand.
A ghost story that just so happens to be entirely true, and next time I'll make you believe every last word of it. The shapeshifter, the starlighter, the one force in all the world that can look into a mirror and somehow tell that it's looking at a mirror. That is where the two of us go next.
3 forces in hand then, and only the strangest one of the lot still left standing.
3 in hand, and one strange one left. Gravity waiting out there in the corner, light and the strong force both behind us now. Colour trapped, quarks walled in, the whole enormous trap sprung out of a single courier with full pockets. Come back next time and we'll finally let the alchemist in through the door.
The shapeshifter. So you've handed me tonight a force that traps, and now you're promising me one that transforms. Trap and transform. That's a strange old pair to end a night on, George.
A strange pair, and a fitting one to leave you with. Tonight was all about the force that will not, for anything, let a thing go. Next time is the force that will not let a thing simply stay as it is. One of them holds, the other one changes, and between the two of them, you're beginning to see it now, a very great deal of the whole world gets quietly built, and just as quietly unbuilt.
I'll be at your door before the birds are even properly up. You know I will. Go on then, hand me the last word for once in my life, and I'll do the sign-off myself.
It's yours, and gladly given. You fairly earned the last word tonight, after taking the very first one so bravely on the chin.
Then here it is. Tonight, you cannot pull a quark loose, not ever, because the pulling only builds its jailer, and colour, which is not a colour, keeps every last one of them walled up inside. Next time, the shapeshifter. Now go and rest your eyes, George. I'll go and fail, gloriously and all night long, to sleep on a word of it.